Hello everyone, this is the problem from Gauss's law. In this problem, they said that a box-like Gaussian surface shown in figure enclosed a net charge which is 20 plus 24 epsilon naught coulomb. And this Gaussian surface lies in an electric field. That electric field is given as a function of basically x and z is a variable electric field. Look at this. This is a function of x and also the z over here. And there is a parameter b with x and z in meter, and b is a constant. The bottom face of this box is lying in the xz plane. So this is your x and this is your z. So this is actually the bottom face lie in the xz plane. And the top face of this box is the horizontal plane passing through that y equal to 1 meter. So this is actually the top face, which is actually at y equal to that length at 1 meter. And from that range is given from x1 equal to 1 meter, x2 actually 4 meter, z1 actually the 1 meter, and z2 basically the 3 meter. Then we have to find out that parameter value b. What would be that value b? Fine. To solve this one, basically we have to use that Gauss's law. So we know that from the Gauss's law, we write, say that flux enclose that electric field dot dA must be equal enclosed charge divided by epsilon naught. Right, so this is, I should write also the net electric flux. This is actually that Gauss's law. We're going to use that one basically to find out this parameter b. Fine. They say that the enclosed charge, this q is said that enclosed charge the given is basically plus 24 epsilon naught coulomb. Then we can say that this finite from the Gauss's law, finite would be q enclosed divided by epsilon naught, which would be give me basically that 24 epsilon naught divided by epsilon naught coulomb, right? So it should be also the plus over here. I have to mention the already of that charge. So that's mean this finite, the flux going to be enclosed by this Gaussian surface would be basically this epsilon naught will be cancelled out, right? It should be that 24 Newton meter square per coulomb, which is the unit of this flux actually. So this is would be that net flux through it enclosed by this Gaussian surface. Fine. Now how I'm going to find out this net flux from this Gaussian surface? This net flux would be basically that sum of these flux of this individual surface. I could write down this flux, net flux would be flux provided by that top surface plus flux provided by that bottom surface plus flux provided by that left surface plus flux provided by that right surface plus flux provided by that front surface plus flux provided by that back surface. I write down the back because I use a b, small b for also the bottom surface. That must be equal 24 Newton meter square per coulomb, right? So this is actually said that the net flux. Fine. Now I have to find out this individual flux for individual surface. So that means the this is actually your front surface, this one back surface, left surface, right surface, top surface, and the bottom surface. Then how I'm going to find out that individual flux for that surface? That I can find out from the Gauss's law, again from Gauss's law, because you know that the Gauss's law is phi for any surface that must be actually that enclosed electric field into dA, right? The area dot product of that one. So now where the electric field is given, which is actually the variable electric field, which I write, say this is actually the 10 plus twice x I hat plus 3 j hat plus b z k hat. So this is my electric field. Now what would be the area? Now the area for different surface would be different, because area is a vector, right? I have to find out that direction also, so that if you want to find out, say I'm going to use a different color for indicating that area vector. Say this one I can express toward that direction would be that d a area towards the right side. Same way I can write, so this would be the area vector direction of d a left one, right? I'm using for different color so it would be easier for me. So say this is would be the area vector for the top. I'll write down d a small t for top, and this one would be the direction which would be basically towards the negative y direction, right? So, and it should be the straight line, I'm sorry, it has to be the straight line. So this one with that d a bottom. What about the front and back? You can easily find out. Say this is would be your area vector towards that direction, which would be that area for front surface. Then this is would be for area vector for back surface, right? That's the direction of this area vector of this 6 surface. Fine. Now I have to also, I can write, say since this area in terms of vector I'm going to express this right surface area vector will be towards the positive x direction, and this will be towards the negative x direction. Top surface will be towards the positive y direction, and bottom surface will be towards the negative y direction. Same as the front surface will be towards the positive z direction, and the back surface will be towards that negative z direction. So then I can write separately this area vector in terms of unit vector. Say I can write in that case d a top would be basically this dA into z hat, right? It's a top surface, I write in it that way actually. So what about d a bottom surface? That must be would be towards the negative y direction, right? So it should be that dA j hat. You can find out. I draw in that form. So this is actually top towards the positive y direction. So this is actually the positive y. Then that dA bottom would be towards the negative y direction. Fine. The same way we can write down, say other one would be, say that dA left surface would be towards minus dA I hat towards the negative x direction, dA right surface would be dA positive I hat, dA front surface I can write it should be dA k hat, and area towards the back surface it should be minus dA k hat, right? So this would be basically the area vector in terms of unit vector. Now I'm going to find out that flux for this individual surface. Say for top surface, and this surface has the different point. So if you think about the top surface, which is basically this one actually my top surface, the top surface would be a particular value for y2, right? Y2 is basically when 1 meter is said that the top surface, look at this, a top surface is a horizontal plane passing through the y equal to 1. That's mean when the y equal to 1 value, then it should be the top surface. Is y equal to 0, then it's going to the bottom surface. For changing the value of y, your surface would be also the different. Also for, you can think about for x, the right surface would be when x2 is basically 4 meter, and the left surface would be when x1, then x1 is basically that 1 meter. And for that front surface, which would be basically at value of z2, which is actually the 3, and the back surface, that would be basically z1, so z1 actually the 1 meter. So that's mean depending on value of x, y and z, your surface would be different. You have to find out on that one. Fine. For the top surface, I can write the flux would be, I'll write f or phi t would be enclose E dot dA top provided at y equal to 1, right? So that's mean when the y equal to 1 along to the y direction, when they say 1, then it should be basically the top surface. Fine. I'll write this case, I have to put that value of that one. Say I'll write, so this is should be ft is 10 plus twice x into I hat, have to use it, plus thrice j plus bz k dA j hat, right, provided at y equal to 1. Now if I take the dot product, you know that I dot I basically the 1, but the I dot j is basically the 0. So that's why this term I dot j and k dot j is going to be the 0, right? They will cancel out each other. Then I will find out this phi t would be basically 3 into dA, for this is actually for top surface. Then to find out that area, I have to write these. I can write, so this area, look at this top surface area, you have to take that variable of this one, say from here to here, so that's mean variable from x1 to x2, and for breadth you have to take that length, right? So it should be z1 to z2. So that's mean I have the two variable, the area along to the x direction and along to the z direction. Then I can write it should be dx and second one will be dz, and this give me that limiting value, right? X1 would be basically 1 2, x2 would be that 4, and z1 would be 1 2, z2 would be basically the 3. I have to integrate that one. Then I'll find 3 into, if you integrate the dx, you'll find out the x, that would be, I just put the value 1 2 4. I can write say x1 2, x2 to 4, and this would be z1 actually 1 2, z2 would be basically that 3. Now you can put the value of that case. So in that case your phi t is going to be that 3 into 4 minus 1 into 3 minus 1. I just put the value, limiting value is today x2 minus x1 and z2 minus z1. That will give you actually that 3 into 3 into 2. That's going to be basically that flux for the top surface would be 18 Newton meter square per coulomb. So this is actually that flux for that top surface. I have to find out that way step by step for that bottom or other 5 surface also. Fine. Now what about for bottom? For bottom surface it would be phi b is going to be that enclosed E dot dA bottom, provided when would be that bottom at when y is basically that 0, then it's with the bottom surface, right? You can find out from that this is actually your bottom surface when y is basically that 0. Fine. So I'm going to put that value. Phi b would be enclosed E is 10 plus twice x I hat plus thrice j plus b z k hat dot, and now the bottom vector actually there is a minus sign, right? This will be that minus dA z hat. We find out, we just put the value of this one, this dA bottom surface is equal to minus dA j hat. Fine. Now using that same idea, I can say that this one x component and the y component would be, sorry, x component and the z component would be the 0, because I dot j and z dot k is basically the 0. So that I can write down that part would be basically the 0. Then I will find out this phi bottom would be enclosed 3 into, there is a minus sign, I factor out into that dA. Now this dA could be written as dx, and also that dz is a x1 would be basically 1 2 4, sorry, x would be x1 2 4, and z limit would be 1 2 3, right? So then I will find this bottom using that one. You will find out minus 3 into, it's a x1 to x2 equal to 4, and z1 to z2, sorry, this would be z2 equal to that 3. Now you can find out it's a minus 3 into, I just put the value, say 4 minus 1 into 3 minus 1. Then I'll find out that 5 bottom would be basically minus 18. You can also find out 4 minus 1, 3, 3 into 3 is 9, 9 into 2, that's going to be 18, minus 18 Newton meter square per coulomb. So this is actually by that bottom surface. Fine. Now for left surface, we can write FL, this is going to be that E dot dl left at, when you can observe from the left surface, when this one, it should be that x equal to 1 meter, right? In that case I will find out the left surface basically, and I should write at x equal to 1, then I'll find out the left surface. But x, if you say that x equal to 4, then we will find out that would be basically that right surface, this one, which is actually x2. Fine. Now I can write, so I'm going to put, so this is phi L, I'm going to put that 10 plus twice x into I hat plus thrice j plus b z k hat, right, into minus dA, because for the left surface towards the negative x direction at x equal to 1. Now I'm going to, you can find out, look at this, this one will be right now cancel out, this z dot I and k dot I would be that basically the 0. So I'll find out only for that x component. Now I can write, so this phi left, and I'm going to put that value x equal to 1 over here, I dot I basically the 1, then I'll find out, there's a minus sign, minus, I'll find out 10 plus 2 into 1, I put the value of x equal to 1 into, this is a minus sign, and I dot I basically the 1, I'll find out into dA, it's enclosed surface. Now I can modify, this one would be minus 12 into dA, so dA I can find for that left surface. I have to find out that area, one is basically that height, which is z1 to z2, and another would be that height, so y1 to y2, that's means the two variable for that left surface, which is y and the z. So I'll write, this would be dy, in that case y1 0 to y2 1, and that dz, which is z equal 1 to z 2 equal to that 3, right? So I just put that one. Now I can find out what would be that. So that this left surface would be minus 12 into y, it should be, I just put that limiting value 0 to 1, and these will be z 1 to 3. Then I'll find out phi left would be minus 12 into 1 minus 0 into 3 minus 1. So that's going to be that minus 24, right? So then I'll find out this phi left would be minus 24 Newton meter square per coulomb. So this is the left surface. Now for the right surface, don't think about it, it's going to be the plus 24 because your x is changing for the right surface, so that's why it's not going to be that plus 24. So let's find out. For the right surface, I'll write down phi r would be E dot dA at x equal 4. So that's mean when the value of x equal to 4, then I'll find out actually the right surface. If x equal to not 4, then it's not going to be the right surface, it will be the different one. So that's why it is necessary. So for the right surface, x value must be the 4. Fine. Now I can write, so this phi r in that case would be close 10 plus twice x I hat plus 3 j hat plus bz k hat into dA towards the right surface. This will be that I hat at x equal to 4 meter, you can say in the. Fine. Now what will be that phi r? In the same logic, I can cancel out this term, must be going to the 0, and this one would be also the 0 because j dot I and k dot I basically that 0. Fine. Now I will find out this would be 10 plus 2 into 4. I put the value of x equal to 4 close into dA, basically I dot I basically 1. Then I'll find out this would be that 18 dA, that I can find out this would be 18 dA. Now this phi r would be 18 into area. For the right surface, you have that variable. The same for this left surface, y and z, right? It should be that dy into dz, and that would be y1 equal to 0 to y2 equal to 1 and z1 equal to 1 to z2 equal to that 3. That's with the limit. Then you can find out, so this phi r is going to be 18 into y 0 to 1, and dz, if you integrate, you will find out z, it should be 1 to 3. I'll find out 18 into 1 minus 0 into 3 minus 1, so that will give me phi right would be 36, right? Plus 36, because 3 minus 2 is going to be basically at 1. Then you'll find out that thing would be, I can write 18 into 1 into 2, that's going to be basically that 36. So I'll write this would be that 36 Newton meter square per coulomb. So my right surface flux would be that 36 Newton. So my right surface flux will be 36 Newton meter square per coulomb. Now come for that front surface. For front surface, what I can write, if front would be E dot dA at Z equal 3, right? You can observe from there, when Z actually the 3, this is actually Z2, I'll find out this front surface, which is Z2 actually the 3, so that's why at Z equal to 3 it would be your front surface. So fine, and from the front surface, your variable for the area, you can find out one would be that one would be that Y, and second one would be basically that this one, which is the X. Fine, then I can write this is for that if front, I'll find out enclose 10 plus 2x I hat plus 3z hat plus bz k hat into dA. Basically this is the front surface, and the front surface is towards the positive z axis, right? So I'll write down dA k hat at z equal 3. Now I can write, so this by the unit vector properties, I dot k would be 0, I dot j would be also equal to the 0, right? Then I can write this front surface would be bz close into dA at z equal to 3. I'll put that value of the z into that equation. Phi front in that case would be 3 into b. I have to find out that parameter b over here, and for dA I'll find out two on one is that dx and another is the dy. So x is basically 1 2 4, x2 would be 4, and y would be 0 to 1. That is the limiting value. Then you can find out, so if you do, you will find out 3b is going to be the x 1 to 4. If you integrate dy, you will find out 0 to 1. Then that flux for the front surface would be thrice p into 4 minus 1 into 1 minus 0. Then it should be basically 9b. So then the flux for the first surface would be that this is 1 minus 0 1, 4 minus 1 is 3, 3 into 3 is going to be that 9b. This would be the flux for that front surface. So the flux for the front surface will be 9b Newton meter square per coulomb, and for the back surface and back surface phi for back would be E dot dA back provided at z equal 1, because when z equal to 1 you will find out the back surface. This is actually the case when z, this is the back surface, when z is basically the 1, I'll find out that back surface. So fine, so I'm going to put that this will be that phi back would be close 10 plus 2x I hat plus 3j plus bz k hat. This is my electric field, variable electric field, dot minus dA k hat, right? Because back surface towards the negative z axis. Fine. By the same analogy, I can say I dot k, this is going to be the 0, and z dot k is also going to be the 0. Then I'll find out this would be phi back would be minus bz input dA at z equal to 1. Now if I plug in the value of z, I'll find out phi back would be minus b into, and dA would be area, which would be that x and y, say dx, x1 is 1 to x2 would be that 4, and that dy is y1 to y2, actually that 1. Then I will find minus b into x is a 1 to 4 is a limit, and this is would be that y would be 0 to 1, right? Then I can write, so this is would be that phi back would be minus b into 4 minus 1 into 1 minus 0, and in that case the phi back is going to be, is 4 minus 1 is 3 minus 3b Newton meter square per coulomb. So that would be my flux for the back surface. Fine. Now I find out that flux for different 6 surface. This is for top surface, this is for bottom surface, this is for left surface, this is for right surface, this is the front surface, and this is for back surface. Now I can write the net flux would be, now phi net, which is flux for top plus flux for bottom plus flux for left plus flux for right plus flux for front plus flux for back, that must be equal to 24, right? We write down the net flux actually must be the 24. Look at this, we find out right here, this net flux must be that 24 Newton meter square per coulomb. This will be my that net flux. Fine. Now I find out that individual flux, then I could write flux for the top surface is 18. I could write that 18, back surface is minus 18, left surface is minus 24. Look at this, left surface is minus 24, right surface is 36 plus 36, 24 plus 36. Front surface is plus 9b and back surface is minus thrice b must be equal to 24. Now this you can solve that, right? You can find that this 18 will be cancelled out. This is going to be the 12 plus 6b minus 24. Then the b is going to be that 24 minus 12 divided by 6, which should be actually the 2, right? 24 minus 12 is going to be the 12 divided by 6 is going to be the 2. That would be that b would be that 2 meter over here. So this is would be that value of this v, and this is the answer of this question. Okay, thank you very much.